Hey students, so this is the last type of difference test that we cover in Marketing 470, and that's the Anova. And an Anova stands for Analysis of Variance and allows you to look at differences that people scored on a metric scaled variable, and specifically you can look at multiple group differences. So instead of comparing two groups as the independent samples t-test did, like for example comparing males and females, the Anova will allow you to look at the differences between multiple subgroups in your sample. So for example, different age categories or different ethnicities or different class standings, for example. So you can compare more than two groups. So let's start right away. So what you do is you go to Analyze, click Analyze, click Compare Means, because again what we're doing is comparing means, and go to One-Way Anova. And if you click One-Way Anova, this is your window, and let's make this a little larger again. And let's see what we want to analyze today. Maybe we want to see if men versus, no, not men versus women. Let's look at different age categories. So we use age categories as our factor. On subjective knowledge about craft beer. Cool. Maybe people of different ages have a different subjective knowledge. Let's find out. So this metric scaled variable, subjective knowledge about craft beer, will become our dependent variable. So of course, what you know from class is that we do have to click the post hoc test. A post hoc test allows you to look at where these subgroup differences could be. So we click, for example, Duncan. There's many others like Sheffy or Tuckies and so on, but Duncan is one of the most easiest to understand, so let's use that one. We hit continue. That's all you have to do. Okay, so you use your metric scaled variable as the dependent and your factor, which is those age categories, or in case you wanted to do ethnicity, you could have done ethnicity or any other categorizing variable. You hit OK, and this is your Anova output. The first table you see in your Anova gives your overall significance for the Anova between your groups. So for subjective knowledge about craft beer, which is that index variable that we created in one of the earliest videos, between groups, we notice that the significance value is 0.090. So this is larger than 0.05, which means there is no significant difference between our age groups on subjective knowledge. Since this is larger than 0.05, there is sufficient support for the null hypothesis, and the null hypothesis says there is no difference. So there's sufficient support for that. We can say there is no difference, no significant difference between our age groups. Now, if this significance value is larger than 0.05, which it is, strictly speaking, we don't even have to worry about our post hoc tests, because the post hoc test allows you, the Duncan test allows you to look at where these differences are between your age categories. Now, since we know that there are no differences between our age categories, there's no significant difference between our groups, we can see that in the Duncan's test, all of these averages for each of the age categories are in the same column. They're all in one column. They're not significantly different from one another. So we see that the average subjective knowledge for people who are 41 to 50 is 3.16. We see that the average subjective knowledge for people who are 51 or older is 3.18, and so on. So we see each of the corresponding averages on a 5-point scale for subjective knowledge for each of these age groups. What we do see is that they're ranked from small to large. We see that in the Duncan's test, the age group 27 to 30 actually has the highest subjective knowledge, namely 3.8167 on a 5-point scale. However, it is not significantly different from any of the other age groups' subjective knowledge. So our overall Anova is not significant, hence why our Duncan's test shows all our results for each of the age categories in one column. Now, if this value would have been smaller than 0.05, which would have meant there would be between groups differences, then in that case we would have had multiple columns, each column for each value that is different from values in another column. So that was it for analysis of variance or ANOVA. Summary is that your ANOVA does the very same thing as a t-test, except that it allows you to look at differences between multiple groups rather than differences between only two groups.